To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
So my dear children, in the earlier chapter we discussed several questions related to the textbook. Okay, so here we are discussing about the lesson part, reflection and the refraction of waves. So over there we discussed several questions in your textbook, my dear children. Now it's time to discuss about several MCQ type questions, however within the extra exercises. So let's first of all start with the MCQ questions, then we'll head on to the other types of questions regarding the extra questions. So my dear children, first of all you are given with a question. See the question number 1. Bouncing back of light rays to the same medium is called. Now bouncing back of light rays to the same medium is called as, my dear children, the reflection. It is the one which is referred as the reflection, right? So bouncing back means when struck on an object, the light rays are going to travel to the same medium. So this is referred as the reflection. Reflection. Next one, property observed in light. So a property observed in light. Reflection, of course we can observe the reflection. Refraction, once again yes, you can observe the refraction as well. Dispersion, of course you can observe the dispersion as well. Dispersion is the effect of scattering light rays or else dividing a light ray into 7 or other different forms, right? So this is also a feature that can be observed in light. So all of these things are features of light rays. Next one, minimum distance of an obstacle and observer to occur echo. So minimum distance to observe echo between the obstacle and the observer should be, my dear children, 16.5 meters. Can you remember? We divided 330 meters per second by 10, or we multiplied it by 0.1 to find out the distance. So within 0.1 second, that's the time interval which the sound is going to retain within our ear. So it is equal to 33. So we divided 33 meters by 2 to get the answer as 16.5 meters. So my dear children, why did we divided 33 meters by 2? Because you know that a certain type of a sound wave is going to travel from a certain observer and should hit on a particular obstacle, and once again it should come towards the observer. So a sound wave is going to travel over there, then once again traveling back to the same position. So a sound wave is traveling like 2 times of the distance between obstacle and the observer. So in order to find out the minimum distance between the obstacle and the observer, we need to divide the total distance traveled by the sound wave from 2. So our answer would be 16.5 meters. Next one, the sense of sound is retained in human ear for about, that is also very simple, my dear children, right? The sound is going to retain within our ear for about 0.1 second. For about 0.1 second, the sound is retaining in our ear, my dear children. Actually, this sense is retained within our brain for about 0.1 second. Okay. After that, we can distinguish the two sounds separately without any trouble. If the reflected sound is coming to our ears, or if the reflected sound is processed by our brain before the sensation of, or before losing the sensation of previous sound, then my dear children, such an incident is the one which is referred as the reverberation. Okay, right. So let's head on to see the next question, question number 5. Disability to distinguish original sound and the echo. So I told you about that thing somewhat earlier, like minutes earlier. So disability to distinguish two different sounds because of the reflection of sound, because of the echo, is referred as the reverberation, my dear children. So go for the answer that carries the reverberation. So reverberation is given in the 4th answer. It's not the double echo, it's not the dispersion, it's not the reflection, but the reverberation is the correct answer. Then the question number 6. Speed of sound in dry air. Speed of sound in dry air. So can you remember when we are doing that calculation related to the minimum distance between obstacle and an observer in order to experience the echo? We discussed that the minimum distance should be 16.5 meters. And over there we multiplied 330 meters per second by 0.1 in order to get the distance as 33 meters. That's the distance which is traveled by a sound wave. So my dear children, our answer should be 330 meters per second. 330 meters per second, which is the first response. Then the question number 7. As per to the figure, tick sound could heard because of. So according to the given figure, my dear children, this is the PVC tube, this is the stopwatch, and the tick sound given out by the stopwatch is going to travel towards the metal or the glass sheet through the PVC tube and getting reflected back to the observer, which is over here. So this is mainly happening because of the reflection of sound waves by that particular surface, right? So our answer would be reflection of sound. Reflection of sound. So the reflection of sound is the main reason to hear the sound by that observer over there, right? So that sound is getting reflected through that metal or the glass sheet which is coming through the PVC tube, right? Then the next question, question number 8. Remedy to minimize the reverberation. So reverberation can be minimized by making ceilings and the surfaces porous, or else by making those things rough. Rough or porous surfaces will not be able to reflect light quite often. So therefore, my dear children, if we are going to make the surfaces somewhat rough, then you can avoid or you can minimize the reverberation process. So let's go for the answers then. Making ceilings porous. Once again, this is correct, no issues in it. I told you that making ceiling porous is a good remedy to minimize the reverberation. Next one, having thick rough curtains. Rough. Once again correct, no. Making walls rough. Once again correct. Rough means correct, because rough surfaces can absorb more amount of sound. So therefore, all of these things are correct. So all of these things can be referred as remedies to minimize reverberation. Then the next question. Question number 9. It is observed that the bottom of a water container has raised. This occurs due to. So my dear children, bottom of a water container has been raised somewhat up due to refraction of light rays. Can you remember? I told you, you should never jump into a reservoir without knowing the actual depth. We have to investigate the actual depth, because the depth that you see is not the real depth. That is referred as the apparent depth. So my dear children, this apparent depth and the real depth phenomenon is going to occur mainly because of the refraction of light. So here also, it is observed that the bottom of a water container has raised because of the refraction of light. Because of the refraction of light. Not because of the reflection, not the dispersion, not the reverberation, but refraction of light, my dear children. Okay. Actually, even light is not going to reverberate, right? Sound is the one which is going to reverberate. Next one. Question number 10. To watch outside from a submarine or a bunker, instrument which used. So to watch outside from a submarine or else from a bunker, we use a certain instrument. By using this instrument, we can look through from an obstacle. Okay. So the instrument which is used to observe this kind of a situation, or else the instrument that we can use to see through an obstacle is the periscope, my dear children. Not the kaleidoscope, but the periscope. We use the kaleidoscope in order to observe vivid patterns, so that we can use those things in designing purposes. The periscope is the one, right? Periscope is the one which can be used to create, right? Periscope is the one which can be used to create that bunkers, the observable things, or the observable instrument which is called as the periscope, right? So therefore, periscope can be used to observe things at a bunker or else within a submarine, right? Within a submarine, for the people within a submarine, periscope can be used to observe the things which is located outside the environment. Okay, so our answer should be periscope. Periscope. Next one, question number 11. Instance where plane mirrors are used as looking glasses. So like I said, my dear children, main purpose of having or main use of having a plane mirror is the looking glass thing. So we mainly use plane mirrors as looking glasses. So this is correct, my dear children. Reflect light in a microscope. Once again correct. To reflect light in a microscope, we use plane mirrors. Next one, in magic shows. Once again correct. In magic shows also we use the plane mirrors in order to create different images, right? So all of these things are correct. Next one, virtual image means. So what do you mean by a virtual image? Virtual image is an image which is created within the mirror. Means that these images cannot be projected into a different screen. We won't be able to observe these images outside the mirror. Okay. So if you take a concave mirror, concave mirrors are not like that. There is a certain instance where the virtual images are getting created within the concave mirror. But however, most of the times the concave mirrors are going to create real images. Real means these images can be projected or these images can be taken into a different screen, my dear children. But however, plane mirror images, all the plane mirror images are created within the mirror. That means these things cannot be taken into a separate screen. So therefore, virtual image means the images which cannot be taken into a separate screen. Can be taken into a separate screen, then it is incorrect. Can't be taken into a separate screen, that should be our answer. This is the answer. Then the question number 13. Not a law of reflection. Not a law of reflection, okay? So there are two laws of reflections. Number one, incident angle is equal to the reflected angle. Number two, normal, incident ray, reflected ray lie on a same plane. These are the two laws of reflection. Now let's see the answers. Normal, incidence ray, reflected ray lie on a same plane. Correct. Normal, incidence ray, reflected ray are parallel. Incorrect. This should be the answer. These things are not parallel to each other, right? Incidence angle is equal to the reflected angle. Correct. That is the answer, right? So our answer should be B, my dear children. The answer, normal, incident ray, reflected ray are parallel. That is incorrect. Okay. Next one. Multiple images are created in cinema halls, jewelry shops, schools, television screens. So the purpose of having multiple images is to enhance the look, to show that there is large number of goods or items. So where do we use these things? Especially within jewelry shops, my dear children. There is only one or two jewelries, but when you keep several plane mirrors, we can get an enhanced look with several items. Okay, so jewelry shops, not in schools, not in cinema halls, not in television screens either, right? So our answer would be jewelry shops. Right, then the next question, my dear children. Question number 15. Sound and light are considered as, you know that sound and light, both the things are considered as energy. These things are not matter, my dear children. These are considered as energy. So both of sound and light are considered as energy types. Both of these things are energy. Next one, multiple images are not observed in. So over there, you can observe, right, The same question, the same answers which was given in the earlier time. So in the cinema hall, you know that we won't be able to observe multiple images. There's no purpose of having multiple images in a cinema hall, no. So cinema hall is correct. In pet shops, once again correct, right? We won't be able to observe multiple images within a pet shop. Then schools, once again the same. So all of these things are correct for the answers. So my dear children, question number 17. Lateral inversion occur, right? So second one, inverted. Number 3, real image. And number 4, image is created outside the mirror. So the question is property of plane mirror image. Now let's recall what we learned, what we have learned regarding the plane mirror images. We studied that plane mirror images are created within the mirror. That means these things are virtual, cannot be taken into a separate screen. We studied that the images created within the plane mirror are erect or else upright images. Then my dear children, we studied that the images, plane mirror images, these images are going to switch the right hand and left hand sides, which is, these things are laterally inverted. Okay. So those are the main features that we can observe within an image of a plane mirror. So now let's head on to see the question and the answers once more. Lateral inversion occurs. Property of plane mirror image. That is the answer, my dear children. Lateral inversion is going to occur within a plane mirror image. So first and foremost one should be our answer. But however, let's look at the other one as well. Inverted, incorrect. Upright, right? Real image, incorrect. Virtual, right? The image is created outside the mirror. Once again incorrect. Image is created within the mirror, not outside. Question number 18. Dispersion of light occurs because of dispersion of light. So dispersion of light is going to occur mainly because of the refraction of light rays. So refraction of light rays should be our answer. So reflection, refraction. Here it goes. Refraction. Then question number 19. Effect of reflection of light, mirage, rainbow, apparent elevation of the bottom of a pond. None of the above. Effect of reflection of light. Reflection. So reflection, because of the reflection, what is going to happen? Mirage. I told you mirage is not going to occur because of the reflection. It is also an effect of refraction. So it is incorrect. Rainbow, once again incorrect. Apparent elevation of the bottom of a pond, once again incorrect. So all of these things are not the answer. So none of the above. None of these are effects of reflection, my dear children. All of these effects are refraction based ones. Okay. Then the question number 20. Speed of light in a vacuum. Speed of light in a vacuum. 3 into 10 to the power 5 meters per second. 330 meters per second. 300,000 kilometers per second. So what is our answer? Our answer is 3 into 10 to the power 8 ms minus 1. So when you turn this thing into kilometers, it is equal to 300,000 kilometers per second. So our answer would be 300,000 kilometers per second. 300,000 kilometers per second. Question number 21. Effect of reflection of sound. Effect of reflection of sound. Okay. Dispersion. Incorrect. Rainbow. Incorrect. Apparent elevation of the bottom of a pond. Once again incorrect. Echo. Of course, this is the correct answer. Echo is heard because of the reflection of sound. Because of reflection of sound, we can hear the echo. So our answer should be echo. Use of ultrasound waves. So you have to select the use of ultrasound waves over here. For navigation, in scanning, in sonar systems, and above all. For navigation, can you remember nocturnal organisms use ultrasound waves for their navigation? So it is correct. And dolphins and whales also use these ultrasound waves for their navigation. So no problem in it. These things are correct. In scanning, of course, we know that to observe our internal body organs, to observe the fetus condition, we use ultrasound scanning. So it is correct. In sonar systems, of course, once again it is correct. In sonar systems, which are being used to find out the depth of the sea, we use the echo sounder, right? The instrument called echo sounder. Over there, we are using ultrasound waves. So my dear children, all of these things are using ultrasound waves. Then the next question. Speed of light is slowest in. Speed of light, slowest. Okay, slowest. That means low. Okay. So when the density is high, speed of light is very low. Okay. So go for the answer that has the highest density. Water, air, glass, vacuum. So our answer should be glass. Glass has the highest density among all these things. So therefore, the higher the density, lower the speed of light. Next one. Ultrasound has a frequency more than 20,000 Hertz, less than 20,000 Hertz, 2,500 Hertz, 20,000 Hertz. So ultrasound is a sound wave which is created to have greater than 20,000 Hertz. So that's the maximum hearing limit, the upper limit of hearing of a human being. So in an ultrasound waves, within an ultrasound wave, there is a sound or there is a frequency greater than 20,000 Hertz. So our answer should be more than 20,000 Hertz. More than 20,000 Hertz. Then the question number 25. Scientist Sir Isaac Newton showed that water is a medium, air has highest speed of light, glass has lowest speed of sound, white light is composed of 7 colors. Can you remember the Newton disk, my dear children? The Newton disk itself refers to the Sir Isaac Newton, who was a great scientist, and he was the person to show that light, the white light is composed of 7 different colors. So white light is composed of 7 colors. Next one. Minimum number of light rays needed to draw a ray diagram. Very simple, my dear children. At the point of intersection, we created the image within a plane mirror image. So to draw a ray diagram, 2 light rays are enough. At the intersection, we can create the image. So 2 is the answer. Next one, question number 27. Instance where diffuse reflection is useful. So you have to select the instance where the diffuse reflection is useful. Number 1 given, using light microscope, incorrect. To get information on the motion of machine parts, once again incorrect. Observe objects in the environment. Now that is correct. That is correct. To separate white light into 7 colors, incorrect, right? That's regarding the refractions. So my dear children, the correct answer for the 27th question, which is the diffuse reflection, is C, to observe objects in the environment. Next one, regular reflection is observed in aluminum sheets, walls, polythene sheets, plane mirrors. Very simple, my dear children. In order to observe regular reflection, the surface must be smooth. So the smooth surface from these 4 is the plane mirror. So plane mirrors, we can observe the regular reflection. Next question, question number 29 and the 30. Select the correct statement. Yes, so you have to select the correct statement. Let's see. Regular reflection is not useful. They're saying that the regular reflection is not useful. Incorrect. Regular reflection is pretty much useful for us. So incorrect. Next one. Speed of sound is slowest in water. Once again incorrect, no. Speed of sound is not slowest in water. It is greater than air in water, right? Next one. Refraction occurs because of changing speed of light, right? Refraction occurs because of changing speed of light. That is correct, my dear children. Can you remember? Because of change in the speed of light, we studied that the refraction of light rays is going to happen. So that is correct. Let's go for the fourth one. To separate white light into 7 colors, plane mirror is used. Totally incorrect, right? We use the prism. Then the 30th question. Select the incorrect statement. Sound needs a medium to propagate. Correct. Sound needs a medium to propagate, right? Because it is a vibration, no. Sound can be reflected. Once again correct. That's why we can hear the echo even. White light is made with different waves. White light is made with different waves. Speed of light is maximum speed in universe. So white light is made with different waves. Correct, right? That is correct. That means this one should be the answer. So can you remember, my dear children, for the extra knowledge I have given you certain things. Can you remember? Over there I told you that actually speed of light is the maximum possible speed which a matter can achieve. Okay. However, my dear children, I told you that the expansion of the universe is even way more faster than that. So the speed of light is not the maximum or the maximum speed which an event is going to happen, right? The speed of light even then greater than the speed of light, the expansion of the universe is going to happen. So when you are checking this question, when you are for the more suitable answer for this question should be the 30th for the 30th one should be the D. Speed of light is the maximum speed in universe. So as they are mentioning about the universe, we can take without any problem the answer as D, because the expansion of the universe, it's happening way more faster than that. Okay, right. So these are the questions for the MCQ questions, my dear children. Now let's head on to see a different type of a question number 2. Now here you need to put a tick if the given statement is correct. If it is wrong, then you have to put a cross. Right. So let's observe the first one. Sound, light are forms of energy. Of course, correct. No problem in it. Sound and light, both the things are considered as energy forms. Correct. Plane mirror shows irregular reflection. Incorrect. Plane mirror is a smooth surface. So therefore, it is going to show regular reflection, not irregular reflection. Irregular reflection means the diffuse reflection, right? Next one. Irregular reflection is important to observe objects. That is correct. Irregular reflection is very important to observe objects. That is correct. Next one. Object can be seen from all directions due to regular reflection. Incorrect. If it is going to show regular reflection, then we will be able to observe only from a one certain angle or only from a one certain direction. Because of reflecting these light rays here and there, definitely we can observe, right, objects from each and every direction. So scattering of light rays here and there is not regular, but it is the irregular reflection or the diffuse reflection. Next one. Plane mirror images are not real. Plane mirror images are not real. Correct. Plane mirror images are not real. Those things are virtual images, right? Plane mirror images are not real. Those things are virtual images. So it is correct, no problem. Next one. White light can be dispersed by using a hand lens. Incorrect. White light cannot be dispersed by using a hand lens. However, we can collect white light into one certain point by using a hand lens. So you'll be learning about these things when you go further with the grades. Like in grade 11, you'll be learning these things about the hand lens and how to use it. Okay. Next one. 2 rays are enough for drawing a ray diagram. That is also correct. 2 light rays are enough, right? 2 light rays are enough to create a ray diagram. At the intersection point of the 2 light rays, what will happen, right? We can observe the image, right? So it is correct. 2 rays are enough to draw a ray diagram. That point is correct. Next one. Plane mirror images are always created in the mirror. Of course it is correct, right? Plane mirror images are always created within the mirror. That's why these images are referred as virtual images. So no problem in this thing. It is correct, right? Lateral inversion not occur in letter O by a plane mirror. Lateral inversion is not going to occur in letter O by a plane mirror. Incorrect. Each and every image is going to create a lateral inversion. However, in letter O, we will not be able to observe it as it is symmetrical. Okay? Because it is symmetrical, the observable image of letter O is observed as the same structure as like this. However, it is being laterally inverted. Because of the symmetricalness, we won't be able to observe it. Okay. So this is incorrect. Lateral inversion occur, but we will not be able to observe it. Okay. Next one. Sound travels at highest speed in a vacuum. Sound travels at higher speed in a vacuum. Light is traveling at the higher speed at a vacuum, 3 into 10 to the power 8 ms minus 1. However, the sound, right, I told you that in order to propagate sound, there should be a medium. Sound is not propagating at all within a vacuum, right? Within a vacuum, it's not propagating at all. So therefore, my dear children, sound travels at highest speed in a vacuum is totally incorrect. Speed of sound in a vacuum is 0, nil. It's not going to move at all. Next one. Light travels at lowest speed in solids. Light travels at lowest speed in solids. Correct. From the media, liquid, solid and gas, we discussed that higher the density, lower the speed of light. So my dear children, light travels at lowest speed in solids. Correct. Next question. Light and sound both are considered as waves. That is correct, no problem. Both of these things are considered as waves. That's why we can reflect these things, right? Both of these things are waves. So within the lesson also we are discussing about reflection and refraction of waves. Waves. So sound is a wave. Right. So these are the answers for the second question. So once again we'll check. Sound, light are forms of energy. Correct. Plane mirror shows irregular reflection. Incorrect. Irregular reflection is important to observe objects. Correct. Object can be seen from all directions due to regular reflection. Incorrect. It should be regular. Plane mirror images are not real. Correct. Because those things are virtual. White light can be dispersed by using a hand lens. Incorrect. Because we are using a prism for that. Next one. 2 rays are enough for drawing a ray diagram. Correct. 2 rays are enough. Plane mirror images are always created in the mirror. Once again correct. That is why those things are called as virtual images. Lateral inversion not occur in letter O by a plane mirror. Actual lateral inversion occurs. So therefore it is incorrect. Sound travels at the higher speed in a vacuum. Incorrect. Sound doesn't travel at all within a vacuum. Light travels at the lower speed in solids. Correct. Because higher the density, lower the speed of light. Light and sound both are considered as waves. That is correct, my dear children. So these are the answers for the second question. Now let's head on to see the third main question. Write two laws of reflection. So let's remind about the two laws of reflection. Now in this question, the question number 3, you had to write down the correct answers. So what are the laws of reflection? Very simple. Incident ray equals to the reflected ray, right? Incident angle is equal to the reflected angle, not the ray, my dear children, right? Remember about the things that you have learned. Incident angle is equal to the reflected angle, okay? Then the second one, incident ray, normal, reflected ray lie on a same plane, okay? Incident angle is equal to the reflected angle, and the second of all, the normal and the incident ray and the reflected ray lie on the same plane. So we'll write down our answers, the two laws. Number 1, reflected ray, comma, normal, comma, incident ray. Reflected ray, normal, comma, incident ray lie on a same plane. Next one, number 2, incident angle equals to reflected angle. Right? Incident angle equals to reflected angle. This is the second law. Next one. Mention the 5 characteristics of plane mirror images. The 5 characteristics of plane mirror images. Let's write. Number 1. Virtual means cannot be taken into a screen. Number 2, upright. Number 3, lateral inversion occur. Number 4, object size and image size are equal. Right? Number 5, object distance is equal to image distance. Object distance is equal to image distance. The 5 properties of plane mirror images. Number 1, virtual means cannot be taken into a screen. Number 2, upright means to the same direction as the object. You can observe the image as well. Number 3, lateral inversion occurs. Right? Lateral inversion occurs means left and right sides are going to switch. Number 4, object size and image size are equal. Object size and image size are equal. Okay. Next one, number 5, object distance is equal to image distance. The 5 properties of plane mirror images. Next one, write 3 uses of plane mirrors. Very simple, my dear children. We'll write down. Used in salons. Number 2, as looking glasses. Number 3, to direct light to a microscope. So over there within the first one, my dear children, I'll write as like this, because as looking glasses and salons, both the things are like same thing, no? In salons also we use these things as looking glasses, no? So therefore I'll write a different one like this. To get multiple images now that's perfect, because now in each of these cases there are 3 different users. Okay, so to get multiple images we use plane mirrors. As looking glasses we use plane mirrors, and to direct light to a microscope we also use plane mirrors. Next one, state 3 effects of refraction of light. 3 effects of refraction of light. Number 1, occurrence of rainbow. Number 2, occurrence of mirage. Then number 3, separation of white light into 7 colors by a prism. Okay, so occurrence of rainbow, occurrence of mirage, separation of white light into 7 colors by a prism. So these are 3 effects that we can observe due to the refraction of light. Okay, right, my dear children. Then the question number 5. Write 3 users of ultrasound waves. 3 users of ultrasound waves. So we use ultrasound waves in number 1, to observe internal body organs. To observe internal body organs we can use ultrasound waves. Here the ultrasound scanning is used, right? Next one, to check the depth of ocean bed. So to check the depth of ocean bed we use the instrument called echo sounder, and over there we are using ultrasound waves. Number 3, for navigation. Of some animals. For navigation of some animals, example bats. Right, so these are the users of ultrasound waves: to observe internal body organs, to check the depth of the ocean bed. For navigation of some animals like bats, ultrasound waves are used. Then the next one, question number 6. State 3 methods that can be used to avoid reverberation. So methods that can be done or remedies that can be done to avoid reverberation. Number 1, making walls rough. Number 2, making rough curtains. Number 3, making the ceiling porous. Making the ceiling porous. So making walls rough, making rough curtains, making the ceiling porous. These are the remedies that we can use to avoid reverberation. Then the question number 7. Mention the minimum distance between an obstacle and an observer to occur the echo with calculations. Right. So here, distance traveled by sound wave is equal to 330 meters per second. This is the speed of sound in normal dry air. Multiplication 0.1 second. This is the time period which a sound is going to retain within our ear. So s to the power negative 1 is getting cancelled with s, and 0.1 into 330 is equal to 33 meters. And now therefore minimum distance between observer and obstacle, right? Therefore, minimum distance between observer and obstacle is equal to 33 meters upon 2, which is equal to 16.5 meters. Why did we divide it by 2? Because you know that sound waves is going to travel from here to there, then once again to the original position. So 2 times as the distance between observer and the obstacle. Next one, an ultrasound wave took 2 seconds to hit on the ocean bed and to reflect back towards the echo sounder. Calculate the depth of the ocean. Speed of the sound in water is 1800 meters per second. Right, a good question. Can you remember, right, when I'm doing this question, can you remember I told you that sound wave is going to emit from an observer, then hit on a certain surface, and once again it should come to the original position. The same thing can be observed within the echo sounder as well. So, my dear children, this is the echo sounder. This is the depth of the ocean. So, echo sounder is going to emit a certain sound wave. It's going to hit like this, and once again it is traveling upward. So the speed by which this sound wave is going to emit is given. How much is that? 1800 meters per second. And it took 2 seconds, see, it took 2 seconds to hit on the ocean bed and to reflect back towards the echo sounder. So total time taken for this procedure, total time is equal to 2 seconds. So the sound wave emitted from the echo sounder is going to hit on the ocean bed and once again come towards the echo sounder within 2 seconds of time period. So first of all, we can find out the distance traveled by the wave. It is equal to speed multiplication the time taken, because you know that speed is equal to distance over time taken. When you multiply both sides by time, time to time is getting cancelled at the right hand side and the left hand side is speed multiplication time. So distance is equal to speed multiplication the time, right? So speed 1800 multiplication time is equal to 2 seconds. Over there also we can observe meters per second, then seconds, second to second is getting cancelled. So you can get the answer as 3600 meters. 3600 meters. Then my dear children, therefore depth. This is equal to 3600 meters division 2, because can you remember, it's going to come and hit and again travel. So twice the depth the wave has traveled. So 3600 division 2 is equal to 1800 meters. That means about 1.8 kilometers, right? 1.8 kilometers. Okay, then let's go to the next question. Write the colors of the rainbow in order. The colors of the rainbow in order. Red, orange, yellow, green, blue, indigo, purple, or else violet. So red, orange, yellow, green, blue, indigo and purple or else violet. These are the colors of rainbow to the order. Then the next question. Mark the components given in the diagram. What is the phenomenon which occurs here? So the phenomenon which occurs here is the refraction of light. As you can see, you can clearly observe it is going to bend and travel. So the components, very simple. This is the incident ray. Incident ray. This is the refracted ray. This is called as the normal, right? Incident ray, normal and the refracted ray, my dear children, right? Okay, so we have answered the 10 questions in third question. Now the question number 4. So fourth question is an explanation. So here you need to explain scientifically. White light is separated into 7 colors by a prism. Why is that? Because my dear children, white light is composed of 7 different colors. So therefore, upon refraction, because of the dispersion, these light rays are separated into 7 different colors. So we can write the answer. White light contains 7 colors. Upon refraction, due to dispersion, due to dispersion, white light is separated into these 7 colors. Right. So this is why through a prism we can observe 7 different colors. White light contains 7 colors. Upon refraction, due to dispersion, my dear children, white light is separated into these 7 colors. Okay, right. Number 2, sound does not travel through a vacuum. So can you remember, sound is a vibration. So to propagate a vibration, medium is essential. Within a vacuum, there is no medium. So sound is not going to travel through a vacuum. So we can write the answer. Sound propagate through matter as vibrations. Therefore, sound will not travel through vacuum as there is no medium. Right. So what is the reason, my dear children? Sound propagate through matter as vibrations. So you know that sound is propagated as vibrations. Okay. So sound propagate through matter as vibrations. Therefore, sound will not travel through vacuum as there is no medium. As there is no medium, it will never going to travel through a vacuum. Right. Next one. A pencil is observed to be broken at the water level when inserted to a glass of water. Very simple, my dear children. Because of the refraction of light, we can observe the pencil as a broken one. So it's very simple. Because of refraction of light, it is observed as a broken one. So because of refraction of light, it is observed as a broken one. Next one. Several sounds are heard inside a big hall even though there is only one sound source. So you know that several sounds are heard mainly because of the reflection of sound, right? So the reflection of sound is causing reverberation. That's why we can hear different kinds of sounds even though there is only one sound source. So we can write the answer because of reflection of sound, because of reflection of sound, several sounds can be heard right. So because of reflection of sound, several sounds are heard. Okay, this is the explanation. Light rays are observed to be bending when traveling through media with different optic properties. Very simple, my dear children. Here, the speed of light is getting reduced or increased when traveling through different optic mediums. So it is observed as bending. So we can write speed of light is changed when traveling through media with different optic properties. Therefore, bending of light rays is observed. So speed of light is changed when traveling through media with different optic properties. Therefore, bending of light rays is observed, right? So this is the explanation for that bending process. Then the question number 6. Womb of a pregnant mother is being subjected to ultrasound scanning, not for an X-ray. Why is that? Because, my dear children, X-ray can harm the DNA. X-ray can harm the DNA structure of the fetus. Right? Of the fetus. So X-ray can harm the DNA structure of fetus. Therefore, ultrasound scanning is used. Right? Therefore, ultrasound scanning is used. So X-ray can harm the DNA structure of fetus. Therefore, ultrasound scanning is used. This is the answer for the question number 6. Question number 7. The ceiling is porous and rough in an auditorium. So in an auditorium, ceiling is rough and porous. Why is that? So it will avoid the reverberation, right? And it will absorb more sound waves. So therefore, reverberation is avoided. That's why it is made somewhat rough, and the ceilings are also somewhat porous. So we can write the answer. To avoid the reverberation to avoid the reverberation and to absorb more sound waves. The ceiling is made porous. Right. So, to avoid the reverberation and to absorb more sound waves, the ceiling is made porous in an auditorium. Right. Next one. Plane mirror images are virtual. Really simple, my dear children. When you take a plane mirror image, these images cannot be taken into a separate screen. So, therefore, these images are virtual. Plane mirror images cannot be taken into a different screen. Therefore, these are virtual. So, plane mirror images cannot be taken into a different screen. Therefore, these are virtual, right? Therefore, these are virtual images. Right. Then the next question. It is important to think carefully before step down into a well or a reservoir. It's because apparent depth is, my dear children, not the real depth, right? Real depth is way more greater than the apparent depth because of the refraction of light. So we can write the answer. Apparent depth is very less than the real depth of it due to refraction of light. So, due to refraction of light, apparent depth is very less. Okay, apparent depth is less than the real depth. Real depth is even more, apparent depth is less. Okay, so apparent depth is very less than the real depth of it due to refraction of light. That is why it is important to think carefully before step down into a well or a reservoir, right? Next one. When a painted circle with 7 colors is rotated fast, it gives the white color. So, white light is composed of 7 different colors. That is why we can observe this phenomena. So, we can write the answer. White light is because white light is made with combination of these 7 different colors. So, my dear children, the answer, because white light is made with combination of these 7 different colors. So, this is why we can observe a painted circle with 7 colors as white color when we are going to rotate this very fast. Okay, right. Then the next question number 27. Explain the given terms in brief with an example. Echo, reflection of sound waves, and traveling back to the observer Example, where can you observe the echo? Echo can be observed in cinema halls. Okay. Reverberation. Okay. So, in reverberation, we can observe, right, the sound waves which are coming from a certain observer, right, or else a sound wave which is coming from a certain source is once again being heard by an observer before losing the first sensation. Okay. So, reflected waves of sound are heard before fading the sensation of the first sound. So, examples, once again we can observe this thing in a cinema hall and also observed in lecture halls, or else we'll write down as the cinema halls, right? Very simple, no? Observed in cinema halls. Right? So, reflected waves of sound are heard before fading the sensation of the first sound. So, we won't be able to identify the sounds clearly. This is called as the reverberation. Next one, regular reflection. Reflection of parallel light rays parallel to each other. Reflection of parallel light rays parallel to each other. Next one, irregular reflection. So, where we can observe the parallel or else the regular reflection in plane mirrors. In plane mirror reflections, we can observe this thing, right? In plane mirror reflections. Then the next one, irregular reflection. Irregular reflection. So the scattering of light rays. Okay, so here parallel light rays scatter after the reflection. Example, by rough objects. Reflection by rough surfaces. Right. So parallel light rays scatter after the reflection. So example, reflection by rough surfaces. Regular reflection, reflection of parallel light rays parallel to each other. In plane mirror reflections, we can observe the regular reflection. Right. Then the next question, refraction of light. Refraction. Here we can write bending of light rays. Bending of light rays when traveling through media that has different optic properties. So bending of light rays when traveling through media that has different optic properties. This is called as refraction of light. Okay, then we can write the example. Refraction by a prism. Right, refraction by a prism. Next one, dispersion. Dividing, right? Dividing white light into seven different colors upon refraction. Right, dividing white light into seven different colors upon refraction is the dispersion. Example, refraction by a prism. Refraction by a prism. So my dear children, refraction of light is the bending of light rays when traveling through media that has different optic properties. Example, refraction by a prism. Then dispersion, dividing white light into seven different colors upon refraction. Example, once again, refraction by a prism. Okay. Then the next one, the echo sounder. Instrument used to find the depth of the seabed. So there is no such example to find out this thing, right? So instrument used to find the depth of the seabed. So we won't be able to provide an example for this thing, right? Okay. Then the next one, ultrasound waves. So sound waves that has a frequency more than 20,000 hertz. These are the ultrasound waves. If a certain sound wave has frequency more than 20,000 hertz, then my dear children, it is called as a ultrasound waves. Okay, then it is called as an ultrasound wave. So in an ultrasound wave, we can observe the frequency greater than 20,000 hertz. Then the instrument used to find the depth of the seabed is referred as the echo sounder. For these two, we won't be able to provide examples, right? Okay. So my dear children, we have discussed all the questions, all the extra questions related to the lesson reflection and refraction of waves, right? So within our next day, we'll discuss the next lesson related to our grade 9 science syllabus. So till then, it's time to say goodbye.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.